Hey, I'm Michael David, and I look after the pump program here at CSI. And we've decided to bring to you a special presentation on pumps. Today's topic is going to be 5 things. And when I say 5 things, I mean, what are the 5 topics or 5 pieces of information that we generally need to know whenever we are sizing a pump for a particular application? So what I did is I asked one of our outside sales guys to join us so that I could ask them some questions, or at least a question, about how they deal with their customers. And so first off, thanks for stepping in. I appreciate you joining us. Now the question I have for you is, when you talk to your customers, which one of the 5 things do you think is the most difficult for them to get, or they may not have right off the top of their head?
I would say the most common thing that I find people struggle with understanding is differential pressure.
And why do you think that is? Why do you think that's the most difficult one?
I suppose the primary reason is most of the people that are purchasing pumps don't really have a salesperson that truly understands engineering and how that pump fits into the process. So they don't do a good job of asking the right questions and helping the person understand why it's important.
Well, that makes sense. So yes, the first one I would say every single time is differential pressure. As a pump guy, we're always going to want to know differential pressure. And what that means is there's a pressure on the inlet side of the pump and there's a pressure on the outlet side of the pump. And the difference in those two is the differential pressure. And the reason that's the big deal for us is we need to know what the pump needs to be capable of either achieving or overcoming to be successful. And in most cases, that's the one that the customer does generally know the least about at the time that they give CSI or one of our outside salespeople or one of our application specialists a call. And so how do we prepare for that? Usually when I talk to customers, I say, talk to me about your process, paint a picture for me, or even better, sketch it out on a napkin. Draw the location of the pump and then draw what's just before it and what's just after it. And then that way we can use that with the line size and flow rate and a few things we're going to talk about in a minute. We can use that to help us determine what the differential pressure is. So we'll do the math, we'll work on that part for you, and so don't worry about it. But differential pressure is the one that typically trips people up because while the pump will help us figure out the flow rate, the motor is determined, or the power is determined by the pressure. So differential pressure is certainly the one that crops up the most as far as people don't have gauges installed on the outlet of the pump. They just don't have a good method for determining what pressure they actually have in the system. So that's always the one that seems to trip people up the most. But we have guys who are good at determining that, and so feed us the information you do have. We'll work from there and try to help you figure it out. So number 2 in my book is temperature. So if we switch from pressure being number 1, we go to temperature being number 2. Temperature plays a lot of different roles. If the product itself might be temperature sensitive. You may have a big swing. If you take a product like honey or syrup or molasses, something that's really thick and sticky to begin with, and then but if you were able to move that temperature even a few degrees one direction or the other, a little bit too cold and it becomes even more difficult to deal with, and a little bit warmer and it becomes significantly easier to deal with. So temperature is one of those things that can play a role on the product's viscosity. It can certainly play a role on the elastomer selection. You have to have elastomer materials that are good for the temperature band that you're anticipating. And then the big one, like I said, viscosity is a big deal. The temperature can change that quite a bit, which can take a product from being very difficult to pump to somewhat easy to pump, depending on how sensitive it is to temperature. So we hit on it there a little bit in temperature. For number 3, I'd say viscosity. So viscosity can very much be temperature dependent, and it can be shear dependent. So, and always when we're talking about viscosity in our world, we're looking at dynamic viscosity or kinematic viscosity. A lot of manufacturers will provide viscosity in sort of this static measurement. And while it's an interesting number, it doesn't really help us as much on pump specification. So what we'll be looking for is the dynamic viscosity, which means if you were to draw out a viscosity curve, you have one part where the viscosity is resting, and that's the product isn't moving. Then you sort of have this transitional period where you're talking about your in-pipe viscosity. So you've gone from resting to in-pipe, and then you sort of have this bottoming out effect where you go from in-pipe viscosity to in-pump viscosity. And so the in-pump viscosity is always the one we're going to be looking for. Good news is, if you're not sure what the viscosity is at the temperature, at the shear that we're looking for, CSI can help with that as well. We have a couple different vendor partners of ours who can do rheology testing for us, which basically means we ask you to send in a sample, we send that sample off to a lab, and they provide that viscosity reading back to us. So that helps with viscosity. They'll want to know what temperature you're planning on processing at, and then we can process that test sample and let you know what the actual in-pump viscosity would be. So if we go on to number 4, in my book, it's flow rate. I said before that the pump dictates the flow rate, and then the pressure dictates the power. And so flow rate's usually the easiest one. It's the one that people almost always know. They typically have an idea of how much they want to pump or how fast they need to empty a vessel. And so flow rate's not usually the one that trips people up. Sometimes they won't know. They'll know pounds per hour, not necessarily gallons per minute, but we can use density and a couple other mathematical tricks there to get from a density to a flow rate. But once we get to a flow rate, we can start sort of narrowing in on a specific pump. So if we know we're trying to flow 50 gallons a minute or 100 gallons a minute, that gives us a good indication as to which pump or pump series to even start with. And then we start dialing it in based on the actual size of the pump that we're interested in. So far we've covered differential pressure, temperature, viscosity, flow rate, and then we're going to go with density. Density will be my 5th thing. Density is the volume or the ratio of liquid to weight. So you may be thinking like water as an example, 8.3 pounds per gallon. And a lot of customers will report their desired flow rate in terms of pounds per gallon or pounds per batch or pounds per hour. They know that they have a certain amount of this product they're trying to make. They just don't know how to necessarily turn that into words. So we have to work with the customer and help them figure out, okay, for this particular product, what's its density? And then we can convert that back into a flow rate. But it's important then again to know what the specific or finished product's density is as compared to maybe some of the recipe components or like some of the parts and pieces that are going to be going into it. And then if I had to pick some honorable mentions, I would certainly go with vapor pressure, which usually doesn't matter a great deal unless we get to really hot products, meaning as you get water closer to its boiling point, vapor pressure can be a big deal. You want to make sure that your inlet condition stays right. And sort of another honorable mention would be particulate size. Some people would put particulate size higher on the list, and when there are particulates, it certainly should be a thing we talk about. But in general, we have 5 things. Those 5 things that your pump experts should be asking you. Give us a call if you want to talk about any of those things. Be happy to help. I would like to thank our special guest, Eric Gore, for stepping in and helping us out. And if you need to reach us, call us at 417-831-1411 or visit us on the web at csidesigns.com.